Hi, good morning. Welcome to the ZP Developer Zone. So every week we do a sort of live streaming webinar specifically for our members of our ZP Developer Zone. I must admit I'm working off different computers today, and I'm actually in a different location. I might even actually have to shut the door in a minute because I realize. Right. So just a quick scenario. I'm actually in Norway at the moment, so things have opened up, let's say, and we are able to sort of travel more around the globe at the moment. You can't see the facility, but this is one of our facilities in Norway. The slight echo is because I'm in my office, so I want to say good morning and thank you for joining us. And I will, yeah, cool. Hi, Ali. Great. So hi, Ahmet. That kind of gives me some reassurance that you guys can hear me. So thank you very much for saying hello. All right. So what I will do is jump into it. Welcome to the ZP Academy. Today we're live streaming from Norway. You know that we have our academy that's open to our ZP developer zones. We do these webinars every week. We do our collaborations every week. We provide jobs and we offer placements. So if you're a ZP Developer Zone member and you've been talking to us, then we're quite happy to have you come with us and do a sort of 3-month, placement with us. And we're in discussions with several people at the moment. Morning, Aftab. Good to see you, man. I know we've been chatting during the week. We have the ZP Developer Zone, which is a website where we have the forum. And we are seriously talking about doing a workshop here in Norway. So as I say, today is a little bit different. I'm streaming to you from Norway. Sometimes it's from Cambridge, sometimes it's been Coventry, because we have labs there, and today it's Norway. So this webinar is driven by our forum and our ZP Developer Zone members. I'm going to talk quite quickly because we have a nice full agenda. Just check the time. Yeah, we're good. So some questions. We've been having some questions about our OEM boards, and I'm actually going to dig into this because I realize that what we have, I call it an OEM board, which doesn't mean something a lot to a lot of people, but I realize what it really is a data acquisition card. We have some questions from Technando about cortisol sensors. We had a question that came in about, are there any non-invasive CGMs? Hi, Saravanan. Good to see you. And we also had some questions about data sheets. So that's 2 minutes of kind of, too much chat. So let's dig into this a little bit. So the first thing I'm going to touch upon today is a little bit of a sort of, I had an inquiry that kind of said, or came in through the forum, we're interested in oxygen measurements. Do you have anything that gives out a 4 to 20 milliamp signal? And the immediate answer would be no, we don't have something that gives out a 4 to 20 milliamp signal. And I know when I was first starting my career, all the time I was at university, I was doing chemistry. I was very much a scientist, sort of in the lab doing wet chemistry. So I definitely hadn't heard of a 4 to 20 milliamp signal. And it was only in my second job, really, that I actually came across this, 4 to 20 milliamp signal. Now, I know that around the table, there's a lot of people around this webinar, there's a lot of people with a lot of experience. So I know for some of you, this is, what this is. But when the inquirer asks, do you have a sensor with an output for 4 to 20 milliamps? In a lot of industrial applications and a lot of process control, you will have transducers. And transducers for me is a subset of transducers is sensors, and biochemical sensors, and, are a sort of subset of those. So, but people are interested in, sensors that can give out a, let's say, 4 milliamp signal when the analyte is at 0 and a 20 milliamp when it's at full-scale deflection, or, for example, the analyte's at 100%. So this is the background to the question, that the guy obviously has, a sort of, I wouldn't say an industrial background, but a more of a sort of engineering and process background. So when you asked about 4 to 20 milliamp, let's say sensors, or signals for 4 to 20 milliamp sensors, what you often have in that system is the transducer itself, you need a bit of a power supply to actually, 4 to 20 milliamps is actually quite a lot of power, especially in this sort of age of portability and low power. And you need a DAC, a data acquisition card. And so it was thinking about this question, which I will start answering in a minute, that I realized that this little board that we have is actually a DAC card, a data acquisition card. So I kind of call it the kind of OEM board, but I realized that actually in some ways what it is it's a USB driven DAC card, and the the data out of it is essentially through a COM port. So no, we don't have a 4 to 20 milliamp, let's say, solution, but I did understand where he was coming from, and we can essentially do it equivalent, let's say, technology, but through one of these, we call them OEM boards, but I realize it's a bit misnamed, and maybe we should be referring to them as DAC cards, really, but maybe even low-powered DAC cards. And I'd say much more modern, because 4 to 20 milliamps, I was thinking about it this morning, I think this has been around for decades, the 4 to 20 milliamp sort of protocol, and it's widely adopted. I get it, it's everywhere. It'll be in the pharmaceutical industry, in the oil industry, in the water industry, in military, it'll be everywhere. But I'm wondering, actually, in this day now that we're going into sort of low power applications, portability, wearables, it's not going to be here forever, actually. And so they'll become more and more niche. Back to the question now. So the question is this. His first question was like, he likes our amperometric OEM electronics, but he wants to know, well, how do I communicate with it? And essentially, what we're doing is we're plugging the board into a PC, and we're communicating with it through a serial terminal, or through a terminal program. Now he actually wants to use Linux. He wants to know what the protocol is, which is actually ASCII. He asks if the sensor is not linear, but the sensor actually is linear. He wants to know a 3D model of the outside dimensions. So I can understand that, when people are asking this question, they kind of want to know the length, the width, the depth, and where the screw holes are for the board. So, because obviously they want to put it into a product. So I do like these kind of questions, because it's no secret at ZP, we're really, sort of focused on getting people to market, rather than, if they're going to do R&D in the lab, it's got to become R&D in the market. It's got to become out there and get onto the market. And now this is the last question, which is, I think, the hardest question, because people ask us, what's the limit of detection of your sensor? What's the drift on your sensor? What's the lifetime on your sensor? But of course, the sensors we have, we will characterize them in an aqueous buffer. But the answer to the question, what's your limit of detection, is the real answer is, what's your application? And I don't, and even if I ask you what's your application, you might say it's seawater. You might say my application is what I call well water from an oil extraction system. So the real answer to that question, what's the lifetime of our sensor, is what's your application, and you have to test the sensors in that application. That if we make generic dissolved oxygen sensors, for example, we will try them, make sure that they actually function, but their lifetime in the application is really dependent on how you engineer the sensor into that application. Do you shield it, or actually do you have the sensor just kind of exposed into the application? Are you inline? Are you online? Are you near-line? These are really important questions, because if you're in the sample, then you're fully exposed. If you're near-line, then you're sort of taking the sample to the sensor and doing. Yeah, and this is correct as well. Ali's saying here, many times you don't need a very low limit of detection. It's right. And that's exactly right. When people are doing continuous monitoring, you're right, they're really trying to just hold the system, between some parameters. It's not like a clinical assay where, you're trying to detect, like, whether somebody has a disease or not, and you want to do it with some confidence. No, I suppose 4 to 20 milliamp means, no, this is a process. It's probably industrial. I probably want to hold the oxygen, concentration in between some parameters. And so, yeah, limit of detection, etc., yeah, is less important. But to the point about the lifetime of the sensor, you have to essentially buy it and try it. You have to buy it and actually put it into your system and figure out, the lifetime of the sensor, from there. So I talked to a couple of engineers yesterday. The nice thing about ZP is, you hear my voice and you see my face, but in this building this is just one of the buildings. There are about 65 people in this building. A lot of them are electromechanical engineers. So I went to see a couple of them yesterday. I wouldn't normally distract them, but because of the developer zone, we run the developer zone as a sort of community service, let's say. So I went to speak to a couple of them, and I knew the answers anyway, but I just wanted to confirm. So the quick answer is I did not expect the answer. I did expect the answer to be positive. If it's Linux, it's fine. You can still use a virtual COM. There's a particular driver here that they recommend, this ftdichip.com. So you have to pull the drivers from there. Yeah, Ali's right. Lifetime and maintenance are important when it comes to online monitoring. That's right. So yes, you can use this with Linux. You have to install a certain sort of driver. There's a link, and I'll probably put that link under the video later on. When he says the communication protocol, essentially this DAC board is just transmitting. You won't be able to send it commands. It will just keep on spewing data out through the COM. So my engineer's like, well, communication, well, it's transmitting, and it's doing it through comma separated ASCII. So you can read, this will kind of be a CSV type file. But essentially, it will just keep on sending. So I think that what you have to do is you have to have a kind of comms protocol and just keep on bringing the data into your application. Because essentially it's the same, a 4 to 20 milliamp signal. It just keeps giving you current, and you have to, log it in some way. So this will just keep on giving you the dissolved oxygen and signal, and you'll have to just keep on logging it. The signal is linear, so you should have no problems there. Now, the outside dimensions, we provide those in the shipping box when you order it, so we have them. Now, the reason we do this is because you will have a lot of people who will ask for all this material. Unfortunately, they don't really want to go forward with it, or they're not, they won't go forward with it for like 2 years or something. So we provide these kind of dimensions, but unfortunately, it comes with the product, not before the product. And he does ask then, he just leaves a hanging question at the end here, conductivity. We did a webinar yesterday with PalmSense. So on this YouTube channel in a couple of days, I will post that webinar, but we did do a webinar yesterday about measuring conductivity. We did it in conjunction with PalmSense. So I'll get the video of PalmSense, I'll post it onto this channel, and then you'll be able to see some conductivity experiments we did. I'm sorry for waffling on a little bit too long there, but in summary, whenever people ask you about 4 to 20 milliamp, it's a common protocol in the control industry. Alice seems to know a lot about it as well. And I think it's a protocol that eventually will go away because it's not low power. And it's kind of been superseded now by, sort of Bluetooth, Wi-Fi, Wi-Fi is even a sort of, we've obviously doing it via a sort of USB cable to a serial port. Yeah, it's a good point here. So Ahmed said, use any filters after you take data. So the quick answer is, Ahmed, this, let's say DAC, this data acquisition card, will just be spitting out data, noise and all. So I agree that this guy has to, because essentially if he's got a stirrer in there, then the mass transport of oxygen could be quite, could be up and down, so he might have to play with filters afterwards, but that's really part of the sort of system development. But no, you're asking the right questions. And then his last question was about conductivity. There is actually a good video coming on conductivity that we did just yesterday in a live streaming webinar, and I'll post that. Yeah, this is just the sort of signal from that DAC cards. This is oxygenated, this is deoxygenated. So if you want to test your system out, you just need a couple of solutions off our web store. One of them which is an oxygenated solution, 100%, and one of them is 0% oxygenated. And then you can just test your system out with that. I'm sort of going a bit faster now because it's 9:15. This is an interesting one. So I've sort of gone to a second question here. So I've sort of spent 13 minutes answering one question. I apologize for being a bit slow this morning. Cortisol sensors for saliva. It says here, I can see that product details say that your sensor is disposable or continuous when required. We often make this statement, our sensors are both continuous or disposable, because when we make like an enzyme sensor, for example, we often immobilize the enzyme on the sensor. So that means you can have it in a continuous stream, a flowing stream, and it will continually read what is in that flowing stream. So they are continuous. If you were doing something like a saliva test, you would essentially have the patient, and this is a bit disgusting, but spit on the sensor, take the reading. You wouldn't reuse it. You wouldn't even wash it. You can't wash it because the contamination risk to the next person is just ridiculous. So, but in an R&D setting, you could take some precautions and wash it and reuse it. So if you're trying to save money, you can reuse these in an R&D setting. In a real clinical setting, and you're having people like spit on something, you cannot reuse it. It's just not ethical to do that. But the sensors themselves can be reused. They're asking another question about cortisol. I'm going to touch upon that in a minute. And then they ask about which potentiostat is the best for product development. So those were the three questions. So yeah, we do have a cortisol sensor. It exists. It's a bit like the oxygen earlier on. In the end, you have to buy them and try them to really figure out whether this is going to work for you or not. We will test them in our laboratory, but we won't be able to test them in absolutely every application. I mean, people are interested in measuring cortisol in sweat. They're interested in measuring cortisol sometimes in the blood, serum, plasma. I've had it before that people are interested in measuring cortisol in saliva. So you unfortunately have to kind of go ahead and try it. I think the lowest cost potentiostat for this kind of work is that Sense It's Smart. So, not because I think it's the best potentiostat, but I think it's the lowest cost potentiostat. Dare I say, on potentiostat, it's probably the best value for money. Now, people are interested in measuring cortisol. Why are they interested in measuring cortisol? Because they're interested in measuring stress. When they say stress, maybe it's more accurate to say oxidative stress. So cortisol, because it's stress, the longer word for stress is sometimes oxidative stress. There are other ways of measuring oxidative stress. ORP, oxidative reduction or oxidative reduction potential. TAS, total antioxidative status. And FRAP, ferric reducing power, FRAP. It's worth looking at these terms. Ferric reducing antioxidative power. It's probably worth looking up these terms. So if somebody wants a simple low-cost sensor, sometimes I will direct them towards an ORP, a TAS, and a FRAP. And we have these sensors also on our website. If you're trying to make a saliva sensor for measuring cortisol, if you're having, first of all, you have to buy it and try it. And if you're having problems, Aftab has one more query to add. So Aftab, ask you a question as I go along. So cortisol is kind of the gold standard for measuring stress, but stress is really so the quick answer is Aftab. We've actually taken these sensors much lower than that. I just haven't put the data on the website. So the quick answer is we're down at the sort of like the 100 nanomolar ourselves these days, because we're measuring cortisol in fish and in fish plasma. So we have gone lower, just haven't put the data on the website. And I think it's really a case that, you know, people will ask a lot of questions, but in the end, people have to try things, you know. If you're trying to measure oxidative stress, I would Google ORP, TAS, and FRAP, and then you can decide whether these sensors will also work for you as well. If you're not sure, really not sure about it, and you're a commercial organization, then you really have to start consulting with people, you know, do paid consulting with people who do know, you know, about this kind of stuff. I realize it's 9:20, so I'm going to go a bit quicker. We did have some questions about non-invasive glucose monitoring, and I think when I look at Ali, Ahmed, Aftab, I think, you know, they know these slides already, but you know, I'm very interested in continuous glucose monitoring and non-invasive glucose monitoring. I've talked about this in the past, that people have been trying to work on non-invasive glucose monitoring for decades. This was a company called C8. They were in California. They were using Raman spectroscopy to do non-invasive glucose monitoring. I think the quick answer is there is not a commercial non-invasive glucose monitor on the market. People have tried. C8 have tried. I've told the guys before now, the ZP developers, members, that some of the engineers from C8 appear to have gone to Apple. So Apple, I mean, I'm wearing my Apple Watch this morning, and you know, so there's a couple of LEDs on the backside of the Apple Watch, and so Apple are trying to use those also to look at glucose, but they've got a couple of patents out on this. Now they're not using Raman, they're using shortwave infrared and medium wave infrared, but I would say that absolutely every part of the electromagnetic spectrum has been attempted or is being attempted to do non-invasive glucose monitoring. So C8 were using Raman, Apple have tried short-wave infrared, medium wave infrared. I'm sure somebody's trying long-wave infrared. I'm sure that I know that people have been using radio frequency to look at this. So I know it's a bit of a bold statement, but every part of the electromagnetic spectrum, somebody has attempted to do a non-invasive glucose measurement on it. And there are plenty of companies across the world trying to do non-invasive glucose monitoring. Now, I think ZP is actually probably a good partner on this, because we are very familiar with doing continuous glucose monitoring development. We tend to do it obviously electrochemically, but we do know a lot about this subject. So I think we're a good partner if people really are trying to do that, especially for validating whether it works or not. But so just some comments about why some of these techniques have not worked so far. So this is the infrared spectrum for glucose. You know, has a very clear absorption, around about 3,000 wave numbers. It has a lot of more features, around about 1,000 wave numbers. This is water. So water has a very strong absorption at around about 3,000, and it has less features around 1,000. So that's a good sign, you know, that it would say to you, you know, by infrared spectroscopy, you should be able to detect glucose in water. The problem comes that if I show you a common organic molecule, I think, no, I'm a chemist. This is acetaminophen. This is a sort of painkiller. It also has an absorption at 3,000, and it has a lot of absorptions around about 1,000 wave numbers. So I'm sort of saying to you, you know, in this part of the electromagnetic spectrum, and I would argue it actually goes in all parts of the electromagnetic spectrum, there's nothing very distinctive about glucose when you look at it versus water or versus other, you know, organic molecules. Now, the thing that makes this a bit tricky as well is that when you look at glucose, it's about 5 millimolar in the blood. When you look at water in the blood, it's about 55 molar. So the ratio, the molecular ratio between these two is 11,000 to 1. The coefficient of absorption is, the efficiency is about 2,000. So water is about 2,000 times more efficient at interacting with a photon versus glucose. So if you take these two numbers, you essentially have a absorption of the infrared by the water versus glucose of about 22 million to 1. So you really have a big signal, a big noise to signal problem here. Then you have to bring into the fact that somebody has, light, dark skin. Their skin can be variable. There's essentially a very small signal, it's a very small signal, and you're looking for less than a needle in a haystack, I think, and that's really what's challenged people. So I agree that you can Google non-invasive CGM and you will find companies. You won't find a product on the market, and you won't find anything that's FDA approved. If you really want to work on this subject, it probably is worth contacting ZP. But you've got to understand that, Apple will have put some tens of hundreds of millions into this. And I think they've quietly closed down that project. Just a warning. The guys know this. Just Google "Hunting the Deceitful Turkey" CGM. The top hit on Google will give you a book that's free to download by a guy called John Smith. This will give you the entire history of non-invasive glucose monitoring. Very quickly now, I've got a meeting starting in 4 minutes, so I apologize to go quick. Somebody was asking about a data sheet for the third generation or NAM was asking for a data sheet for the third generation of CGMs. Third generation of CGM is when the enzyme interacts directly with the glucose, and then from the enzyme, the electrons go straight to the electrode. I have played with third generation CGMs, but there isn't one commercially available. We have a data sheet for a first generation. I think that maybe the question is, do you have a data sheet for the second? So if the question is, do you have a data sheet for the second generation, then the answer is we should do. Put it in the forum and I'll give you a data sheet for the second generation. And I think that's it. Sorry for the 13-minute discussion on OEM. Cortisol, you probably have to try and buy and try that cortisol sensor. Do your book work on ORP, TAS, and FRAP. Non-invasive, yes, there are plenty of companies trying it. I absolutely assure you. Read The Deceitful Turkey by John Smith. It's a good read, and happy to give you that data sheet. Just clarify that you want the second generation. All right, I am 3 minutes from a meeting, so I do have to go to it. Aftab, thanks for the questions this morning. Ahmed, thank you for the questions on filtering. Ali, I agree with you. Actually, in an industrial process, limit of detection is not such an important thing. It's just controlling the process. Saravanan, thanks for joining again. And I will see you guys soon. All right. Thanks, guys, and take care. Bye-bye.